Practically, the resistance of an ammeter should be very, very low. Why effective resistance should decrease? How a galvanometer can be converted into an voltmeter. Under what modifications galvanometer is used as an voltmeter is always connected in parallel. Sir, ideal ammeter should have low resistance. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, PU College, Mysuru. Moving charges and magnetism. We are interrelating the concepts of electricity with the principles of magnetism. We are at the fag end of this chapter. And what is that I have in store today? Two important topics where we learned how a galvanometer can be converted into an ammeter, that is conversion of galvanometer to an ammeter. And next we will study how a galvanometer can be converted into an voltmeter. Typically, the second conversion is also explained in your practical sessions. So, my dear students, we will take up the first type of conversion, that is conversion of a galvanometer into an ammeter. So, ಈ ಸೆಷನಲ್ಲಿ ನಾವೇನು ನೋಡ್ತಿದ್ದೀವಿ? ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್. ಯಾವ ರೀತಿಯಾಗಿ ಒಂದು ಗ್ಯಾಲ್ವೆನೋಮೀಟರ್ನ ಆಮೀಟರ್ ಆಗಿ ಮಾರ್ಪಡಿಸಬಹುದು? How can I convert a galvanometer into an ammeter is what I discuss at the starting. My dear students, in order to understand how a galvanometer can be converted into an ammeter, I should know the basic difference between a galvanometer and an ammeter. I should know what is the purpose of using a galvanometer. What is the function of an ammeter? And only then I can understand how galvanometer is converted into an ammeter. ಹಾಗಿದ್ರೆ ಏನು ಗ್ಯಾಲ್ವೆನೋಮೀಟರ್ ಅಂದ್ರೆ? ಏನಿದು ಆಮೀಟರ್ ಅಂದ್ರೆ? In my previous class I told a galvanometer is a device which will detect the presence of current in a circuit. Or being more clear, it is a device which will detect very, very small currents in a circuit. You will establish that through an experiment called current sensitivity or figure of merit. Please do know, a galvanometer will only check the presence of current in a circuit, or it will detect very small currents only in the range of microamperes. A galvanometer can detect very small current only in the range of 10 power minus 6 ampere, microampere. And therefore, to measure the strength of higher currents in a circuit, like 1 ampere, 2 ampere, 3 ampere, that is where I am using an ammeter. So kindly know the difference, students. Galvanometer detects the presence of current. Ammeter measures the strength of the current in a circuit. Current, anything higher than 10 power minus 6 ampere is detected or checked using an ammeter. So, what is that I am doing today? I will understand under what suitable modifications, suitable changes, I can also use a galvanometer to function as an ammeter. ಏನು ಸೂಕ್ತ ಚೇಂಜ್ಗಳನ್ನು ಮಾಡಿದ್ರೆ ಗ್ಯಾಲ್ವೆನೋಮೀಟರ್ ಅನ್ನು ಹೈಯರ್ ಕರೆಂಟ್ಸ್ ಮೆಜರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನಾ? ದಟ್ ಈಸ್ ವಾಟ್ ಐ ಆಮ್ ಸ್ಟಡಿಯಿಂಗ್ ಇನ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಕನ್ವರ್ಟಿಂಗ್ galvanometer into an ammeter. Vidyut pravahamapaka. Very beautiful. In Kannada, the device goes on by saying Vidyut pravahamapaka. Now, to begin with, as I told, an ammeter is an instrument used to measure electric current in a circuit. Wherever you need to measure the strength of the current, 1 ampere current, 2 ampere current, 3 ampere current, I use ammeter in that part of the circuit. So in the circuit, wherever we need to measure electric current, which device we use? Sir, it is ammeter. Good. Now, how do I connect an ammeter? Any circuit where you have used an ammeter, kindly recall it. Circuit where you verify Ohm's law, you use an ammeter. So in any circuit, wherever you have used an ammeter, it is always connected in series. Very important, students. In that part of the circuit where current has to be measured, ammeter is always connected in series. So just remember your Ohm's law verification, resistance per unit length circuit. Wherever current has to be measured, an ammeter is connected in series. Why? It is very simple, because if you remember your circuit where 2 resistors are connected in series, When do you say two resistors are connected in series? We say two resistors are connected in series when same current flows through them. If 2 ampere current is flowing through a circuit, I want my ammeter to measure that 2 ampere current. This can happen only when it is connected in series across two conductors like resistors connected in series. Current will not change, will not vary. Therefore, an ammeter is always connected in series. And therefore we say an ideal ammeter should always have zero resistance. My dear students, typically asked for 1 mark in the exam. What is the resistance of an ideal ammeter? An ideal ammeter should have zero resistance. Practically, the resistance of an ammeter should be very, very low. Why? Again, as I told, it should measure the actual current flowing in the circuit. If it will resist that current, oppose the flow of current, then actual current is not measured. True current is not measured. Therefore, we say an ideal ammeter has zero resistance. The resistance of an ammeter should be zero. So we see here, an ammeter is an instrument which is used to measure electric current. And any part of the circuit where current has to be measured, ammeter is connected in series. Why ammeter is connected in series? Wherever there is series combination, there is no change of current. Actual current is measured. And therefore, the resistance of an ideal ammeter is zero. Now, with these 3 considerations, what modification has to be followed to convert a galvanometer to ammeter? What are the changes I require to convert a galvanometer to ammeter? Remember, students, galvanometer has a considerable resistance. Experimental check martira figure of meritally 50 ohms, 60 ohms, 100 ohms resistance irutte. So please note, a galvanometer has considerable resistance. But an ammeter should have practically very low resistance. For an ideal ammeter, true ammeter, the resistance is zero. So in order to convert a galvanometer into an ammeter, I should reduce the resistance of the galvanometer. How will I reduce the resistance? Connect one more resistance in parallel. What is that resistance called? Shunt. Shunt means low resistance. So please to follow this. Practical Vaivadali question keltare. A galvanometer is converted into an ammeter. I am converting a galvanometer into an ammeter by connecting a low resistance. How? Parallel with the galvanometer. A low resistance called shunt resistance has to be connected parallel with the galvanometer. Under this modification, a galvanometer is converted into an ammeter. Now, this is the relevant circuit which shows the required conversion. So this is the galvanometer of resistance G. G denotes the resistance of the galvanometer. I have to convert that galvanometer into an ammeter. Good. Which means I have to reduce its resistance, decrease its resistance. So what is done? A low resistance called shunt resistance is connected in parallel with it. So I am connecting a shunt resistance, shunt, small, low antartha. A shunt resistance is connected in parallel with the galvanometer. See, now the galvanometer and the shunt are in parallel, and my theory told the two resistors are connected in parallel, so effective resistance decreases. Why effective resistance should decrease? Sir, ideal ammeter should have low resistance. Good. Now, we say Ig is the current for full scale deflection in the galvanometer. What is Ig? Current for full scale deflection. Enidu full scale deflection andre previous class I told a pointer galvanometer has 30 divisions on either side. So this is a pointer galvanometer. It has 0 to 30 here, again 0 to 30 on each side. So on one side of the galvanometer, 30 divisions. I want the pointer to deflect completely by 30 divisions, full scale. A pointer complete at 30 divisions move agbeku. I require some current, that is called current for full scale deflection. I maximum current in this circuit. So I is the maximum current flowing through the circuit. And how did I get I minus Ig? Did I study this anywhere? How can I write I minus Ig is the current through the shunt? Yes, sir. You have taught us in our Kirchhoff's law. This is the point where a galvanometer and a shunt is connected. What did we call such point as? Sir, it is a node. Very good. Junction. So I is entering the junction. It is positive. Ig is leaving the junction. It is negative. Therefore, current flowing here is I minus Ig. ನೋಡಿ ಸಿಂಪಲ್ ಆಗಿದೆ. ನೀವು ಪ್ರೀವಿಯಸ್ ಚಾಪ್ಟರ್ ಉಪಯೋಗಿಸ್ಕೊಂಡ್ರೆ ಕಿರ್ಚಾಫ್ಸ್ ಲಾಸ್ KCL concept is there. So I enters the node, it is positive. Ig leaves the node, it is negative. So I minus Ig is the current flowing through the node. So Ig, current for full scale deflection where? In the galvanometer. G, resistance of the galvanometer. I, maximum current in the circuit. Yes, shunt resistance connected in parallel. I minus Ig, current through the shunt. Now, since G and S are in parallel, very clearly you see galvanometer and shunt resistance, they are connected in parallel. For parallel combination, what should be same, students? Sir, we have already learned voltage or potential should be same, which means potential across G should be equal to potential across S. Why? Sir, they are connected in parallel, two types of resistors, so voltage should remain same. Very good. So, potential difference across the galvanometer should be equal to potential difference across S. How do I calculate potential? Sir, Ohm's law, simple. We have learnt it very thoroughly. What was the mathematical form of Ohm's law? V equals I into R. So potential in terms of current and resistance, V equals I into R. So potential across galvanometer, current is Ig, resistance of the galvanometer is G. Potential across the shunt, current is I minus Ig, resistance is S. Therefore, from that, expression for shunt resistance is Ig into G divided by I minus Ig, a very important expression. So, in order to calculate the low resistance, the so-called shunt resistance, what is the use of that shunt? Reduces the resistance of the galvanometer. We have S equals Ig into G divided by I minus Ig. So beautifully you see here, if an ammeter is connected parallel to the circuit, I expect that I connect an ammeter parallel in the circuit. What will happen? It is connected parallel, so resistance should decrease. Resistance decrease adre current flowing through the galvanometer will be large, which will spoil the meter. That is why always ammeter is connected in series. Good. Now, coming to the second part of the conversion, where we learn how a galvanometer is converted into an voltmeter. under what modifications galvanometer is used as an voltmeter? Now, what is an voltmeter? Again, you have used this several times in the circuit. Voltmeter is an instrument used to measure potential difference in a circuit. Potential difference andre no exclamations. Very simple. It is a device used to measure voltage in a circuit. Any part of the circuit where voltage has to be measured. I am using a voltmeter. Voltameter bere ide, where electrolysis is measured. Here it is potential or voltage. So how do I connect voltmeter in the circuit? Voltmeter is always connected in parallel. Voltmeter is always connected in parallel. Why? When two components are connected in parallel, voltage remains same. So when I say voltage remains same, actual voltage is measured. So please to understand, in a circuit, to measure current, ammeter is connected in series, and in a circuit, to measure voltage, voltmeter is connected in parallel. And the resistance of an ideal voltmeter is infinite. Again, a very important 1 mark question, again based on Viva. The resistance of an ideal voltmeter is infinite. So please to understand, voltmeter measures potential difference, or it measures voltage in a circuit. How do I need to connect an voltmeter? I have to connect voltmeter parallel in the circuit. Why do I connect it in parallel? Voltage has to be measured. True potential has to be measured. When two components, two conductors, two resistors are connected in parallel, potential remains same. And the resistance of an ideal voltmeter is always infinite. So with all these considerations, how do I convert galvanometer to voltmeter? Voltmeter has infinite resistance, practically high resistance. Galvanometer has some 100 ohms. So if galvanometer has to perform as a voltmeter, its resistance should be very, very high. So what do? I connect high resistance in series with the galvanometer. When two resistors are connected in series, effective resistance increases. Therefore, students, if you observe this circuit, a galvanometer is converted into an voltmeter. How? By connecting high resistance in series with it. Galvanometer as an ammeter, low resistance called shunt in parallel. galvanometer into voltmeter, high resistance in series with it. Therefore, again Ig, current for full scale deflection in the galvanometer. G, resistance of the galvanometer. V, this is the maximum potential across the circuit. R, high resistance connected in series. Now from Ohm's law, again, since I'm measuring potential, V equals I into R, or V equals I, current through the galvanometer. And if you observe, G and R are in series. Therefore, effective resistance is R plus G. This R is nothing but effective resistance. R plus G, or V by Ig equals R plus G, or high resistance is V by Ig minus G. So this is the expression for high resistance to be connected in series. So my dear students, in my today's session, we have understood two important modifications. How galvanometer is converted into an ammeter. How do we do that? Sir, by connecting low resistance. What is that low resistance called? Shunt resistance. In parallel with the galvanometer. And the galvanometer is connected or converted as an voltmeter. How? By connecting high resistance in series with it. In my next session, which will be the last session on this chapter, we will understand the working of a cyclotron. Until then, please go through whatever is done. Thank you.